Symmetric cryptography. Symmetric cryptography, also known as secret key cryptography, is a fundamental component of modern cryptography. It involves the use of shared secret key by both the sender and the receiver for encryption and decryption of the message. The key is kept private and must be securely communicated between the parties. Encryption process. In symmetric cryptography, the encryption process involves the conversion of plain text into ciphertext using the shared secret key. The plain text is divided into fixed size blocks, and a mathematical algorithm is applied to each block, along with the secret key. This generates the corresponding ciphertext. The decryption process looks a little something like this. The receiver, having the same secret key, performs the reverse process to decrypt the ciphertext and retrieve the original plain text. Bazinga. The decryption process applies the inverse algorithm to the ciphertext using the shared secret key. Now, with that comes a few strengths and weaknesses. Symmetric cryptography offers several advantages, including simplicity, efficiency, and speed. It is well suited for encrypting large amounts of data. However, one drawback is the necessity of securely transmitting the secret key to the recipient. Well, with that being said, let's talk about the opposite. What about asymmetric cryptography? Well, that's a good point. Asymmetric cryptography, also referred to as public key cryptography, provides an alternative to symmetric cryptography. Unlike symmetric cryptography, which uses a single shared secret key, asymmetric cryptography utilizes a pair of mathematically related keys, the public key and the private key. Public key encryption involves the sender uses the receiver's public key to encrypt the message, right? While the receiver uses the private key to decrypt it. The public key can be freely distributed wherever, allowing anyone to encrypt messages intended for the owner of the private key. With that, you have the use of digital signatures. So asymmetric cryptography also enables the use of digital signatures to ensure that data integrity and, of course, authentication. The sender uses their private key to generate a digital signature, which is then appended to the message. The recipient can verify the signature using the sender's public key by confirming the message's authenticity. Now, again, with this comes a few strengths and weaknesses. In asymmetric cryptography, it provides advantages such as secure communication without the need for the prior key exchange, right? However, this type of encryption is computationally more expensive than a symmetric cryptography, so it makes it less suitable for encrypting large amounts of data. And then with security as a whole, you have hash functions. Hash functions play a crucial role in computing and cryptography. They are mathematical algorithms that take an input, known as the message, and produce a fixed size output, known as the hash or digest. Hash functions possess important characteristics such as collision resistance and pre-image resistance. Now, collision resistance, it's a hash function that is considered collision resistant if it is improbable to find two different inputs that produce the same hash value. In other words, it is highly unlikely to find a collision where two distinct messages have the same hash. And then pre-image resistance referred to the difficulty of determining the original message from its hash value. So given a hash value, it should be computationally infeasible, right? To find any input that yields the specific hash. Now with hash functions, you have applications. And they are very useful with cryptographic applications. So They're commonly used and employed in password storage, digital signature, and blockchain tech. The security of many cryptographic protocols relies heavily on the collision resistance and preimage resistance properties of the hash functions. This is what makes it secure when you use them as signatures or verifications for transactions or blockchain. In summary, the fundamentals of cryptography section of this course dived into the essential principles and techniques of the cryptography. So you should have more of a solid understanding about the different encryption algorithms, protocols, and how to manage keys, which of course at the end helps you to dive into it yourself and develop secure and private systems, protecting sensitive information and ensuring the integrity of the data of your business or yourself in today's digital world.